All right. Welcome to OCWG meeting number 11. And yeah, we can go ahead and jump in. I think Max, you had said you've been doing some work. You want to talk about the stuff you've been working on?
Yeah, I think it will be a good point in the discussion right now because try to summarize the design decisions we took so far and try to figure out which are most open and identify two topics that we need to somehow resolve. Maybe I start with the open topics and then build up why they are open.
Yeah.
So the open things are like, what is the role of JSON schema for OCWG? I mean, JSON schema is nice to describe formally the structure of a document.
Mm-hmm.
But what we want to have is a composite structure. So we define the base structure, and then we have extension points where we define how the extension works, and then applications can define how their part works. So we can only say that there are things that we don't know about and that somewhere else it needs to be described. And to sort of validate a whole document using JSON schema, I think it's just not possible just out of the box using JSON schema, because this is the use case it's breaking what JSON schema can do. JSON schema works if you say, okay, here's an object and it has some additional properties which we don't know. So we just ignore them all. That's fine. We can validate that. And then we could have a JSON schema for the subnode and say, this defines its own schema. And in order to validate it, you need to actually copy out this stuff and validate it using that schema given there. But then you are no longer validating the whole schema, the whole document. It just, you cannot say validate this given this information. We need some custom code in order to validate stuff. So yeah, and we don't know which applications will be in the extension, so we cannot list them.
So what I understand you saying, let me make sure I'm understanding what you're saying, Max. You're saying that there's two options here, and neither one of them are very satisfying. One is that we could have a schema, a JSON schema that defines sort of the base capabilities of the OCWG spec. But then there's these extension points. And the only thing we could do with a singular JSON schema is basically ignore all of the extensions, like not validate them. We could just say, it's okay if there's stuff over here, but we can't say anything about it at all.
One other option is to say, here is a list of schemas which we know, and one of them must match on the node. So then we wouldn't have to maintain a registry for all existing schemas. And
right.
This is not what we want. So JSON schema is...
Well, gotcha. So then, like, just to represent this other idea, you'd have the base JSON schema, and then you'd have these other JSON schemas, for each one of these other extensions, basically.
And then you use the one-off to include the sub-schemas and have them validate the nodes.
Gotcha. You use what to include the sub-schemas?
One-off.
I don't know what that
That's
means.
a keyword in JSON schema. Within JSON schema, you can say this subnode needs to match one of those schemas. So it's with a capital O and no minus.
Gotcha.
The keyword, yeah. And it's just one F. So it's one of these schemas.
One of.
Yeah. Yeah. Sorry, my English pronunciation.
No worries. I got it.
And yeah,
I see what you're saying. So we'd have to include, and the problem is we have two problems there. Then we, in order to use subschemas with this option 2, we would need to include all possible schemas, like subschemas, or
in our schema
registry that you would like be able to look up the schema from some registry that we've maintained.
So validation of the whole document, including extension out of the box, is just not possible using JSON schema. It's too flexible. And JSON schema is still nice to describe structure. And then we have a little conflict between having a nice JSON syntax, very compact. I mean, we discussed whether it's property bags or just using property prefixes. And property prefixes are certainly harder to model in JSON schema, to say everything that has this property prefix, so it matches this regular expression, has these properties, or belongs to this app, or can be looked up in that schema. Actually, that cannot even be expressed in JSON schema. So we could make a very boring JSON structure, very verbose and easy to describe in JSON schema, or more compact and clever syntax that also has more shortcuts to state some other things, and then making the schema more complex. So this is a trade-off decision where we have to find a balance.
Gotcha. And was this one of the ones that you were saying that you were trying to write up the decisions we've made thus far?
Yeah, I put them in the spec repo, in the pull request, in the spec repo, in the pull request branch.
Great.
And there in the file decisions, not the SVG, the middle one, the markdown file. Yeah.
Great.
Yeah.
Cool.
And this is where we made a list of these open issues, and then the design decisions we took so far, and what we deduced from them, and what inspiration we took into account. And we can walk through this in order to enlighten ourselves. Wonderful. So JSON schema, that's one thing where we have to sort of take a decision as a group. How important is JSON schema for us? Is it a nice byword, we use it as good as possible, or we tune the syntax so that JSON schema works better? It will not work excellent ever because of our flexibility, but we can tune it. But there is no other tool besides JSON schema to describe the structure of a JSON document. I mean, the only other option would be to say JSON is just a carrier and JSON linked data is the message. And then we describe our structures in RDF, what structures we actually have encoded. But frankly, I think we would alienate more JSON developers because JSON linked data and this RDF stack brings just a complexity that's not helpful for the goal of interchange here.
Yeah, I agree. We've at that point we've gone so far afield from like the from the Obsidian's JSON canvas world, where there's just like this human readable, not even JSON format, more like YAML, and then we've gone all the way to like RDF and JSON.
Okay, so that's for JSON schema. We keep that in our mind. And the other issue, which is mildly related, is structures. I mean, we have decided very well on resources and on nodes and on embedding schemas and handling assets. And I think that's all quite understood. But structures, where we discussed about groups and arrows and sets, and so if you think more about structures, this is encoding semantics of the app. Like you have a group, you delete the group, all the items in the group are gone. So we want to capture that.
Right.
But in some tools, if you delete the group, the items are not gone. So this is a group. And then it becomes really hard for arrows. So we have the simple case. We have an arrow, it connects two things. So in the visual part, we have a node A, we have a node B, and we have an arrow C. And then we have a structure that says actually that arrow that is depicted in C is actually starting in A and ending in B. Fine. So what's the implication? If you delete the arrow C, then this linkage structure should probably also be deleted. If you delete the linkage structure, should the visual arrow also be deleted?
And when you
be.
say structures, we've talked about these as relations before,
Yeah,
right?
relation. Sorry,
Okay,
yeah,
cool.
relation. That's the same. Um,
Yeah, this one definitely
yeah, but
covers.
if you, okay, um, relation, right? So these interaction semantics for the relations are
Hmm.
tricky, and also they are not completely decoupled from the visual part, because as we saw in the arrow example, you actually could
Right.
see the relation. um, then for groups, I found in the note that like a typical group in PowerPoint is just a logical group, but the
Hmm.
group in Obsidian Canvas is a spatial group. It's a rectangle, and what's inside is in the group. I found in your
Right.
note, I think. So I think so.
Hmm.
An Obsidian Canvas group resembles much more a node than a relation, somewhere somehow.
Hmm. Hmm.
And these structures are really tricky. And maybe these relations, and maybe these relations are like special nodes. So we also
Hmm.
have the case of invisible nodes, hidden nodes. So in some
Hmm.
tool, you had a node that was visual. The user decided to hide it. It's still there. It still has a position, a color, a stroke, a freeform hand drawing, everything like a visual node, but it's hidden currently. So is it still a node, or do we have to migrate all that stuff into a relation in order to not show it, because nodes are always
You,
displayed?
I think I understand the arrow one, and I have some thoughts on that one when we get. Can you restate the second example you were saying with like hidden nodes? I'm not
Yeah,
sure that I follow the problem there.
yeah. If we have a node that is hidden, which is,
Uh-huh.
I think, a reasonable thing that the user
Yeah.
can hide a node,
Hmm.
then it's no longer visible. So how do we encode that? Currently,
Hmm.
we should have a relation that says, I'm pointing to only this one node in order to make it hidden. And the tool that cannot hide nodes has to show it.
Hmm.
Or we have to even pull all the data that the node had into the relation in order to hide it, because the node should not be visible. So the data needs to be hidden in a relation. So that
I
relation
see.
would say,
And
I'm
what
almost like
you're
a node.
Yeah, what you're hitting on is the way that we defined nodes are the visible things on the canvas, relations
Hmm.
are the invisible things on the canvas. And so you
Yeah,
hide a visible thing, that becomes an invisible thing. And so it should be represented by a relation.
which
Um, I don't know that one to me, maybe I'm oversimplifying it, but just I had never thought of that problem before, and coming to it immediately, it makes it feel like the fact that it's hidden, it isn't really a relation.
it
That
isn't, no?
hiding
Right?
is just a visual. You're basically saying, I want this visual artifact to still be around but not appear, and that's just an implementation detail of the visual layer. It's not actually a relation at all, is
I
my.
think that would be a good resolution for that special case. Yes, I agree.
Okay.
And
So,
then,
so I have a question about these relations and structures and groups. Uh, is there going to be a way to specify that a node is a child node of another node, or that a node is a parent node of another node? Because these parent-child relationships are very common in game engines, in
Hmm.
GLTF, and I don't know about infinite canvas tools, but to me, parent-child relationships are very important. And I did mention before that like I might want to implement this in Godot engine. If it didn't have parent-child relationships, that would severely limit like how useful I think that would be, you know.
Yeah.
yeah, that's the perfect next point, because of course, a group in many tools, a group can contain other groups, and that's one way to encode nesting. So our current natural way to encode parent-child relationships amongst nodes would be to say either we have a group that has some members, and among the members is another group containing yet another node, so that implicitly forms a tree, or we would add a new relation type, the parent-child relation, add that into the relations part. The visual nodes themselves don't know about that relation, but the relation parts adds the structure there. That will be sort of the current natural way to do it. And yeah, given other tools I've seen, it it might feel unnatural for people to split relations and nodes. And I thought about the split. So we have resources and we have nodes. And there is a split makes a lot of sense because some nodes display the same resource over and over and over again. So we have an n-to-m, one-to-n relationship. One resource can be displayed in a number of places. So what kind of relationship do we have between nodes and relations? Theoretically, a large number of relations could reuse the same nodes. But if we would promote relations somehow to nodes themselves, I'm not sure that's a good idea, but let's discuss it. Then, yeah, these relations might become simpler or feel more natural. So we could embed like structural or relation properties into the node and say, yeah, actually now nodes can contain other nodes and can have a parent node. And then it would be more compact and also conceptually maybe be easier. I mean, all the other tools I've browsed through during my research don't do the split. That you just have a visual node and you can say, actually, I have children. And then maybe if you have a group which is not visible, you say, okay, I'm a visual node, I have children, but actually, although I'm a visual node, I don't have a position and don't have size. So that blurs the relation, what is a visual node. Then a visual node is more a node.
Right, and
And
that
some
would
of the
allow
nodes,
those children that don't have a position to just inherit that position from its parents.
for example. So and then if we would go that route and say we have just nodes, then all the visual properties become like a like an extension part. Yes, some of the nodes actually are visual, then they have visual properties, and some of the nodes maybe are not visual. They have no position, no dimension, or something. So we would have, I don't know, node types. I mean, it's in the end, it's different ways to express the same thing. Like if you have a node that is type visual, type structural, that's more or less like having nodes and relations in the first place. But still, it might be easier to grasp if we combine it more.
Yeah, that's interesting. I'm not sure that I'm understanding the same problem, understanding the problem's gravity in the same way. So you've clearly been digging into this for a little bit. I think to remind all of ourselves of the design decision that got us here, or the design principle that got us here, was we wanted to be able to support both conceptual canvases, so things that have that are, it's like the visual representation is secondary and the semantic relationships are primary. And so an example would be like React Flow or that kind of thing, where you have a code flow diagram where you may not manually specify the locations of the nodes, but you let that you have sort of auto layout engines and that kind of stuff that are based on the semantic relationships between the different between the different nodes on the and so we were hoping to have a concept, which we're currently calling relations, that would model the semantics without at all entangling the visual representations. And so that was how we ended up here. May not be a good idea, but
Yeah.
and you're pointing out some problems. My very simple thinking about this is that relations always can optionally point to a node, or potentially based on the type of relation, it might be able to optionally point to a set of nodes, but that to kind of say this semantic thing is tied to that visual thing. But that is sort of an optional pointer to further give more semantic information about the way. And I guess we need to get into some specific cases in order to demonstrate that. But the way that I was thinking about it too is like groups even mean different things. They're represented differently in different canvases, right? So you pointed this out with Obsidian. I came across the same thing. Obsidian groups are more like a node And I would actually argue that they are a node. They're not actually a relation at all. And you might argue, you might represent them with both a group node that's obsidian typed and a group relation that happens to point to that. But you could get rid of one and still have the other. And then it really comes down to like, how do we encourage implementers of this to represent, how do we help people represent their canvas in OCWG in a way that could be consistently interpretable by other people who are sort of reading the canvas, which I think is maybe where you're getting to.
Yeah, what you just mentioned, that the distinction between visual things and non-visual things is sometimes not as clear. I mean, arrows are another example, especially connectors or ports. Ports
Right.
I also stumbled about them. So what is a port? A port is a visual thing. It's like a corner of the rectangle. The relationship is that actually this node is always auto-computed based on that other node. And you can attach an arrow to it, which I'm listing in this other relation. We have an arrow attached to the port.
Right.
It does work to split it up, but also maybe it's a cumbersome split.
Yeah, maybe
I
it
think I
is.
suggested it in the beginning, but
Right.
now I have my
Yeah,
doubts.
exactly. Like I said, maybe we're wrong and it's not a good idea, but it does feel like what we will end up doing is we will end up with an analog node that's an exact analog of the relation thing, which is like a semantic node that is non-visual. And it happens to now be in the nodes array as opposed to in the relations array. But we need the same thing. And I'll give you
It's
another example of like a
it's
place where you need
almost the same. There's still one difference, namely this deletion semantics. If you delete a node, it's gone. So let's say if the node has an ID and it
it.
contains members because it's actually a group. And if you delete the node, it's gone. If you have the Obsidian Canvas node example and you delete the visual node, then the relation part still lingers around and you need additional computation to consolidate. If this is deleted, that should be deleted. And it's this unit of having a node with all properties attached to it
Mm-hmm.
is maybe the thing we can gain.
Right. No, that's a good point. I think it might. Oh, go ahead, Michael. Go ahead.
You can convert from a system that has nodes inside them, to the relation.
Yeah, the expressivity is the same
I
on
have it. I
both
have it
models.
implemented already in my system as a test.
And what experience have you made? Did you like it? Did it feel like a good idea or cumbersome? I mean, what?
Yeah, it's well, it's there's a converter layer in between, so it feels a bit. I can show it how it looks, and that's maybe better than just talk about it. Now, let's see if I.
So while Michael's pulling that up, I do want to mention a really important difference between parent-child relationships and other relationships, is that the parent-child relationship is a special case where the child nodes inherit the transform of the parent. So this isn't necessarily the case for other relationships, like with an arrow. If you just have arrows connecting nodes, then the arrow would just, you know, move as it needs to connect the nodes. But it's a parent-child relationship is very direct, when the parent and the child have the transform relationship.
Mhm.
And that is important because it affects the rendering of the scene, you know.
Yeah. Yeah, exactly. We haven't even, I don't think we're even yet, I think we have not tackled relative positioning or uh we're thinking that everything will be like a global position. But that actually there might be some problems for that because some tools might actually only store the offsets within like a group or something along those.
Another consideration is the composability of Open Canvas documents. If you want to combine like two Open Canvas documents into one, you probably don't
Mhm.
want them to be overlapping each other. So you might want to like give an offset. So conceptually, that is itself a parent-child relationship. So if you're going to have parent-child relationships in that case anyway, you might need this
Yeah.
as a fundamental feature.
Yeah, and I think the parent-child relationships, yes, I think we need to figure out how we're going to model those. The current plan is to use a relation that would be an edge that specifies this, this child is related to this parent. And then you would model that as these two nodes have that relationship through that relation object, which to Max's point ends up being an entirely different kind of thing than a node. And does it need to be a different kind of thing? Should that just be a field on a node that allows it to like point to a parent? Yeah, but Michael, go ahead, like take it away.
Yeah, in my tool, this is a node,
Okay.
a container node, but it has all these elements in them, and connections and nodes are all nodes. Connection is just a node with a different node type, but these are inside this container. You can see the JSON storage
Mm-hmm.
here. So these nodes, that's this, and if I collapse all these nodes, that's everything that's in the canvas itself. And when I on the right side here is the OCWG representation, not the exact latest spec version, but something that I made some time ago. But the relations are in here. So this set describes this container with these child nodes, and all these nodes are in one big list together with all the other nodes. So as a format that's used to port information from one tool to the other, I think this is probably fine. But I think this reads more easily. You can't see because this is one big list. You don't know if this is a child node or parent node. You can only see that if you look it up under relations. So this is less human readable, I think, than if you have a structure like this. That's but as a format that you use for sending canvases between other canvas applications, then of course then I think this could work. But
yeah, that makes sense. So yeah, there's a level of indirection in the it's like if you want to know whether a node is related to any other nodes, then you have to go look it up in relations. But again, this is only for groups, right? Like off has a relationship to toggle inside your group, and toggle has a relationship to on, and those have to be looked up as well, right?
Yeah, I think because I specified my own schema over here, so I think I also put it under the properties. I think. Oh.
Gotcha. They're part of the properties for the node itself, right?
That's also what I do myself in my own format.
Interesting. Max, this is more I guess this is kind of making your argument here of like his instinct is to have the relationship between the nodes stored on the node itself rather than going to create a separate edge relation to model the relationships between those things.
But I do have something that might be need to be stored in relations. Let's see if I can. This is a more complex flow, but this has hidden. With this button, I can show the hidden dependencies.
Yeah.
And they are my application knows determines these hidden connections by looking at, for example, this calculate centroid. That's a function name.
And so they are like computed relations.
Yeah, but if you want to store this in OCWG format, then you might want to have this
a relation
as well, but under relations, not.
I think I
maybe.
think my instinct here comes from working with text editor formats. So I was working with a text editing format called Standoff, which it my instinct is to think of relations as annotations on top of the visual layer. Like there, and this is, here's a good example of this. In Excalidraw, there is no explicit this node is related to this node by this arrow. When you draw an arrow, it doesn't, they don't have any notion of, on the actual arrow object, they don't have any notion of like from this node to this node. It just has like points where the arrow starts and ends. So they kind of, in my view, they have like a deficient view of arrows on the canvas, right? Like that those clearly, if I'm drawing an Excalidraw and I draw an arrow from this object to this object, I'm saying they have a relationship, and there's some from to relationship between these two things. Excalidraw just drops that on the floor entirely in their internal model. Like they don't have that concept. Um, on the other hand, TLDraw does. When
Yeah.
you, and TLDraw has this rich notion of like it goes from this node to this node. It also has some things about the computed point at which the arrow arrives into the shape and all that kind of stuff, which is the stuff that Excalidraw has. And so in my view, TLDraw is a better annotated canvas for semantic information than Excalidraw is. But that's going to be up to the individual implementers of the canvas of like whether they think of their canvas as something that is visual, or if they think of the semantic information that's embedded in the visual and try to represent that semantic information in some way when they're exporting it from OCWG, and then also deal with that semantic information in some way when they're importing it from OCWG. So I think I'm still seeing the value in like pushing, especially this one that you're showing right now, k-means clustering, where you can have an arbitrary number of from two relations between any node, that makes me want to put them somewhere else, right? Where I could even like truncate all of, like ideally you would be able to drop the relations node, the relations array completely and load it into a canvas, and it would appear exactly the same. Now it wouldn't function the same, right? Like if you tried to grab a group and like drag that group, the group object might be completely gone. The grouping, all of those relationships are gone, but it should look exactly the same. Max, you've been thinking about this most deeply
Yeah,
over the last,
the two jQuery cases are connectors and points.
Connectors, okay.
So what is a connector? It's like we have, let's say, a binary connector. We have two nodes, then we have a path traveling on the canvas, reaching another connector, another node. Now the interaction semantics are that node is moved and the path is recomputed according to some rules. And canvas tools differ quite a lot on these rules, like whether they use straight lines or these clever round lines that switch around at a certain point and whatnot, and that use another connector point inside to define the connection or the shaping behavior, or like in PowerPoint where you have control points on the connector. So how would we model control points on the connector? You have a,
I mean, those are definitely nodes, right? Like
you
that's
can
a node
see
problem.
them
How is that? I
sometimes.
don't understand how that's a relation problem. It's like, tell me more.
Oh, it's more like a property of the connection itself, the connection node type. Because you
What-
mean
Okay,
this-
yeah, it could be modeled as relation. So that means if you move the node, you see the relation. This was actually an auto-computed connector. Now, if you can rerun the routing algorithm, and if you don't, do some sensible fallback, like let the user draw the connector again.
Shouldn't the position of the connector just be anchor points? And an anchor point being a number from 0 to 1, where 0 is, for example, on the left side or the top side, and 1 is the bottom or the right. And this is a 2D coordinate, so there's two of them. So like 0, 0 would be the top left corner, 1, 1 would be
There's
the bottom right
more.
corner. There's
Like
more?
Yeah, you don't not only have rectangles, like you can have rectangles that add more connector points. Tools
It-
differ in this respect, how they handle connector points. Sometimes you can define your own connector points using sort of relative coordinates within the thing.
Yeah. No, the
It's-
rules
Well-
definitely differ all over the place on this one.
Well, you don't have to do it on the edge. You could do like 0.25, 0.25 or something.
Yeah, so
Yeah, this
what
is
are you showing me?
one way. Like TL draw,
Make
even
the-
it has
yeah, make
this
the
special
shape
control
bigger.
point in the middle where you can change how the arrow actually is bent, I think.
Michael,
In the middle
make
of the
shapes
arrow.
bigger. Make the shapes bigger, and then you'll be able. I know what you're trying to do.
Oh,
The shapes
yeah.
have to be bigger in order to do it.
Ah.
Now, yeah, if you have a bigger shape now, you'll be able to drag that connection point to like any arbitrary spot.
Yeah. That was what I was trying to do.
But again, this is what we're talking about seems to me to be a purely visual thing that has nothing to do with relation. It's like what you're doing right now. None of the things that you just did change the relationship from rectangle to oval. The relation object would stay the same in both of these, in these cases. That never changes.
Where would I encode the information where these control points are defined? And where would
So-
I
Right. That would be
add?
encoded. It would be encoded on the node. And Orion and I did some work on this exact problem because he was very familiar with it from because you just witnessed Michael showing the weird way that TL draw does this. So he was saying, here's what it would look like for a TL draw. Basically, the TL draw arrow needs to have some additional information in it that allows it to, when it's pointing to an object, to be able to define exactly the XY inside of that object where it's anchored to. And that algorithm, when pushed into another tool, it's not going to look the same.
Of course not, because there are too many different algorithms, clearly.
Way too many different algorithms. And so
But we still want to round trip the information that TL draw put in so that we go back into TL draw, we still have the same arrow if possible.
Yes, agreed.
So these control points need to be stored in the arrow. So these are extensions of the arrow, but the arrow is a visual thing. So
right.
the TL draw arrow has special coordinates which are located in the nodes that are referenced to by ID. So suddenly the TL draw arrow is referencing other nodes by ID. Isn't that what relations are usually doing? Referencing nodes by ID?
Kind of. Yeah, we never said that we never said that nodes can't reference other nodes.
Yeah.
Yeah, so I don't have a problem with like a node saying, this is
Okay.
I'm pointing into this, and I think the way that TLDraw does this internally, by the way, is like a relative coordinate system within that shape that it's pointing to. So we're gonna have to encode the this is the node that you're pointing to, and here's the relative coordinate within that node. Because that's just the way that TLDraw does this.
That's basically what I was suggesting with the anchors. It's just a relative coordinate system.
Yeah. And again, I think all of this is visual. Like you can do all of these things without representing a relation, and you can also have a relation that represents square points from, there's an arrow, a relationship, an edge from square to oval. And that's just a semantic relation that has no visual that may not have a visual representation on the canvas. In this case, it does because it has the arrow, but that's where I was kind of getting at with the idea of having a pointer from the relation to the to the visual node. Like we could have relations have an optional pointer to nodes that says like, here's the node that visualizes this. It could be, maybe call it visual node, that is related to this relation. But the deletion semantics, again, it feels like the deletion semantics need to be so Max, right? We're thinking of like a static format. Why do you think we need to encourage implementing authors to implement specific deletion semantics? Is that why you're hoping to think through this?
Yeah, what's happening? We have tool A exporting stuff, loading it in tool B, user interacting with tool B, adding nodes, changing nodes, deleting nodes. So it would be great if we would not leave like orphan data from the point of view of application A, which is quite tricky. And that's exactly what makes these relations. What makes them important to define them very precisely with regard to deletion semantics. For example, we might end up having two kind of groups. One is the group that deletes its members, and one is the group that will just disappear if you delete it. And then sometimes you want to express this or that, or I'm not sure. But on the general discussion whether we have nodes, worthless relations, or merge them or not, I think it's also fine to keep them separate. Giving all the discussion we had now, we can say, yeah, there are nodes. They are meant to be visual. They can be hidden. They can refer to other nodes, so they can carry quite a lot of relational information if they need to. But we encourage tool authors to put purely structural stuff into the relations array to try to split visual information from more structural information. And this is also an option. I mean, I think it's fine. And then this would ease using Open Canvas for non-visual tools, actually, I think, because you don't have to artificially create nodes in order to hold anything. You just have relations. But the distinction is not that hard because a relation also needs to have an ID so that it can be reused in other relations. And so it's two similar things, but we built them for different purposes.
Yeah.
That's
I'm with
fine.
you. Yeah, I'm with you. It's it is a challenging divide, but yeah, this is exactly where I had written in my notes of like, I think maintaining relations enables support for more semantic first tools, and makes it easier on them because they're not having to deal with all these sort of visual nodes. They can just say, here is the semantic relationships. Now, I think like it's going to be really interesting of like what happens if you export from a pure semantic tool, like even think of like a GraphViz type tool, that it just has, nodes and their relationship to each other. There's really no, and then GraphViz is all about auto layout. Like there is no manual layout thing. What happens when you try to export one of those to OCWG? You end up with like just a relations array and no nodes array. What happens when you open that in TL draw? Well, there's nothing to see. And so I think you would almost need to like you'd need to run like for a pure semantic tool, you need to like freeze the visual state to some layout before you export it, right? So for like GraphViz, for example, a GraphViz to OCWG exporter might also run one of the layout algorithms to generate the visual nodes in a specific spot and then allow you to like manipulate that in TL draw. But if you bring that back into a GraphViz based tool and rerun the auto layout, you've destroyed all of the like location information that you, but that's okay. Like that's a natural consequence of using the two tools as they're intended.
I agree.
Cool.
Shall we quickly go over the 8 requirements which I identified? So you can just say whether you agree or disagree that this is actually a requirement we want to support. So we want to be offline able, so that the tool should run offline.
Right.
So we need a way to store content into a file. But we also want to support dynamic use cases. So let's say weather forecast, which cannot be stored in a file. So it's okay if an Open Canvas file refers to a remote URI as well. So both, it's not a contradiction. We just want to have both options, be offline able or be dynamic. Then we want the graceful degradation. That means if we have some content that cannot be shown, we might have a fallback content that can be shown instead. We want to be extensible, which is actually a core thing, that an app can store its data and get it back after round tripping. And then these apps need to play together nicely so that app B doesn't destroy or change data from app A in a way that makes it incomprehensible to app A. But we found mechanisms already to deal with it. Then human-friendly was a thing that appeared often, that we want to have a syntax that is still usable in the plain text editor and does make sense, and it's not too weird.
Right. We're not using binary. We're using something
for
that you can actually
example.
scan.
Yeah.
Cool.
Then reuse, we want to reuse existing standards and formats as far as possible to not reinvent the wheel, which is, for example, problematic for composed JSON schema because there the standard just doesn't go far enough. We want to be precise so that we can clearly define what actually the spec means, which elements must be present, and if they are. And then we have like special things in precision, like numeric precision. How can we, what exactly can we guarantee or think about? And then, for example, we need to think about text rendering. We need to be precise enough that text rendering trickiness doesn't destroy the rendering too much. That brings us to the next, visual fidelity. So we don't even aim for the 100%, but again, text rendering is a tricky thing because I found in Excalidraw that they later introduced adding line height to text item to combat different browsers having different default settings for line height. So text rendering is actually a deep problematic thing. Having different fonts, hyphenation, auto hyphenation breaking at borders depends on your hyphenation rules or your hyphenation dictionary you have present. And then maybe you know this famous Stack Overflow post about parsing HTML with regular expression, and there the author uses a lot of Unicode to actually bleed the page and looks just horrible. Unicode is very powerful and might become your enemy. Then we have maybe as a special topic for visual fidelity to think about transparency and Z-index. So we have, let's say, web resources, we have texts, we have freeform scribbles, we have images, and these freeform text, and all of them might have some transparency. And now if they are put together in a 2D rendering, this transparency is actually really important. What actually is visible in the end, or do all these tools support transparency? Like I don't know, a drawn circle and the inner side is actually a transparent color. So this Z-index color handling transparency is especially relevant for us. And then, color spaces. I don't know, maybe we just need to define which color space we actually support or why that's not a problem. And then even minor things like path stroking. They're not fully defined. Like the edge case of a path that always, like a Bezier curve, always making a cusp. What actually is happening at the cusp is different among tools. And if the line is very thick, then you do notice it and it bleeds over other parts. But color space and path stroking are like minor issues. I think text rendering and transparency are more what we need to look at. Then I listed some sample applications, mostly Excalidraw, because that's so nicely structured in our different GitHub discussions. And it has so many issues in one simple list. I think there are not so many surprises we learned from that list. Just some thinking about synchronization as an upcoming topic, but the other parts are nice. Then for resources, I think that, now for the design decisions, right? So we decided to split nodes and resources and also relations. We decided the resources are mostly like web resources, so we can reuse what we know about them. I think there in your preview, you cannot see the rendered diagrams. They are in the SVG, which is this PR preview editor not showing. Never mind. So we have probably textual content, which is easy to embed. We have binary content, which, we put into the assets. We support different content formats. We might have to mint out some of our own content formats. For example, for these freeform scribbles, I think they appear very often. They play a very central role in Canvas tools, but there is no existing freeform tool that sort of combines the path information and the style information into one file. I mean, SVG probably comes close.
I was going to say SVG is what I was thinking. We had discussed.
But SVG is just much more complex. We could say, use this SVG subset for representing freeform drawings. And then, maybe. Then schemas, we have not yet found out how much we can use schemas and what we can define, but we found out we can easily embed schemas using our asset management mechanism. So embedding schemas should not be a problem. In general, for assets, I think we discussed everything and found good design decisions to put stuff in the main file, next to it in asset files, or maybe at remote URIs. And then using the hack of data URIs, we can even embed short binary things in the main file, not requiring an asset. So that is sort of easy. And structures, the more you think about them, yeah, you just, for every single structure, you very clearly need to define what this structure actually means, this relation. Sorry for relations. I used structures throughout my document. Relations. So to precisely define what does it mean to have a port? What are the semantics of the port? What needs to be known about a port? Yeah. And often it's about deletion. But for a group, for example, you can also like move a group, and then the usual semantics are like you move everything. And I don't know if you worked with vector graphics as a teenager, but if you have a document that uses characters and suddenly all the characters are transformed into paths, yeah, it does look the same, but the interaction semantics are just so broken that you would consider it just wrong.
Yeah.
And I think similar things might happen here if we get basic relation things wrong. But as we saw for the auto-computed connectors, there are so many apps doing so many different things that we can only define some base relations, and then other applications need to define their extensions, their special relations, like how, or maybe like in Obsidian, in TLDraw, the information is encoded on the visual side, like this arrow actually has these anchor point offsets. Yeah. So for these relations, I think we should dig a bit more into them in the next time to nail down what is the minimum required core set we need to support. And then we could, following the human syntax idea, define some shortcut syntax to say, okay, if you write this in JSON, it's actually equivalent to this more cumbersome JSON. Like if you say ID blah content hello, that implies you actually created a resource with an anonymous ID or auto-created ID, which you referred to, and it actually had the content type text plain. That's actually the same thing you said. And I think we can add some of these shortcuts in order to make very small sample files in order to get started.
Right. Yeah. Very terse examples. This looks great. I mean, really nice work, Max. I think I am definitely in agreement on the
Requirements
for design principles. Like thumbs up on those. Michael or Aaron, did either of you, well, and speaking specifically of those design principles, were there any that were a surprise to either of you?
No.
or missing?
Or missing? Yeah.
No, not yet. I'm going to read it more carefully, but
Yeah.
it looks already very complete.
Cool.
Yeah, we can always extend it.
Right. No, I think that like a great capture of where we've been. I think the one area where yeah, like we've already talked about today, like structures. This definitely diverges more from the relation stuff we have in the specs so far, because we defined edges, sets, edges, and hyper edges, I guess, were the three. Not saying that those are everything or that has to be it, but yeah, we just had a very different notion of relation. And I see how you were kind of talking about an arrow as being a structure. I think if we separate the semantic,
we should rename it here then into edge again to be more relational, more logical. Yeah, less visual. I agree.
talk about it. Yeah, let's talk about it next time. I think that's a good topic to hit at the next meeting. Because Orion and I spent some time thinking about sets, edges, and hyperedges, and thinking about how you would model a whole variety of relation like objects, like things from groups, as well as how arrows might work, parent-child relationships, to Aaron's point. And I think a lot of it can be handled, the semantics can be represented. Now, whether this is a nice, semantic representation or not, and whether there should be pointers to nodes and that kind of stuff, there's some open questions still. Good stuff. Michael, when you've had a chance to review the doc, let me know. I'm gonna also take a quick glance at it in the next couple weeks, and maybe we can go ahead and get the design decisions merged in.
Yeah.
I think one of the ways that I've done design decision docs in the past is using there's this format called architectural decision records, ADRs, from Michael Nygaard, I think originally pioneered it. And he kind of has here was the conditions that here were the goals, here were the options we considered, here were the things we chose, and then there's like the implications of the choice. It's like, because we chose this, the following, and that doesn't mean that all those implications are positive, right? It's not about a positive negative thing. It's like, we made this choice, and therefore here are the therefores. And so, but I think what you've got is plenty formal for kind of the stage of kind of the process right now. But in the future, we could use some format like that. We could propose a design decision. Maybe we do that with relations, for example, since that seems like one of the ones that's up in the air of like, and then we can kind of iterate on it from there.
Maybe we can also try to reformat it to an ADR.
Yeah, we could try. They can be pretty short. They're not it's not a bulky format at all. I think there's like 3 different sections. Cool. Good stuff. We're at 1 minute past our normal meeting time. Does anybody else have anything to cover or discuss before we break?
I will go and summarize, or let AI summarize our meeting.
Tell me what's wrong with this spec, AI.
That's a good one. Improve it.
Yeah, improve it. Exactly. What are the areas where this is going to break? Here, read the TL draw documents or docs, and read the Excalidraw docs, and write me a and give me a sample file that matches the Excalidraw doc. That'll be interesting.
Related to that, though, it is important for the design documents that we explicitly list compatibility goals and interoperability goals, because we want to. We don't want to, like, just straight up copy one tool's format, of course, but we want to ensure that anything that we do is implementable in every tool we intend to support. So we should probably list explicitly some tools in the design document, like TLDraw, Excalidraw, that we want to be compatible with those.
That's a really good point. Yeah.
That's actually a tricky thing. If we go just for the base and say we are extensible, then we are a format doing nothing. We just say, yeah, we have positionable nodes that don't do anything, can't do anything, that's it. Or we add more features from other tools so that they are no longer extensions but core. Then we need to define explicitly what they mean, and where do we end? This is actually not so easy.
It's not trivial, but at the same time, I think there's sort of the Lindy whiteboard tools. It's like that we all kind of know. I think we could pretty quickly get to a set that we're like, let's at least have these in core. Maybe we add new things in core later, but just like having shapes and arrows and text, it's probably like, that's probably good enough to get started. And then you kind of, then we have, like, to your point, then an OCWG file is something, right? It's not just nodes that are positionable, but you at least have a few things that you can build off.
Yeah. I would also argue that images should be in the base spec too, because images seem like pretty fundamental.
Yeah.
I can give you what, and it's also good to note that there's plenty of things that we can think of that like are pretty much a solved problem by now, but we don't want to have them in the base spec. For example, physics. Like if we want to have like objects in your canvas like moving around and bouncing around and stuff, that's really cool. But that should definitely be an extension because there's a lot of open canvas tools where that's not a feature at all. So that's that's, by the way, one of the extensions that I could build because I've been working on that on the GLTF side. So I could pretty much just copy paste it and change it around to work with canvas elements.
That would be
Cool.
really neat. There are several people in the Orion Reed and others in the sort of open canvas or the infinite canvas space that have done a lot of physics on a canvas stuff work. There's some fun stuff. People like building sand simulators and that kind of stuff, and hauling sand simulators and that kind of stuff inside of a canvas, and pretty wild. That's awesome, Aaron.
It's on my
All right.
bucket list to build that.
Maybe this year at 21 Days of Code during December, you can work on a sand. Good stuff. All right, guys.
Cool.
Until next time, we'll be following up after this.
Yep.